All right, here we're going to learn how to send things from Excel into Microsoft Word, which really is mostly copying and pasting. And also how to change a little bit the appearance of your graphs and tables if you want to change the color or something like that, or excuse me, adding grid lines or something. So this is like a 2-for-1 because I'll go over part of your summer assignment here where we're going to plot the area. So I'm going to make a graph of radius versus area, so I do need to have the radius in my worksheet somewhere. So I'll put in a column for that. I'm going to determine experimentally the area of these circles. And I'm also going to use, I should not try to talk and type, God knows. Look at I'm spelling these things right, that's amazing. I'm also going to use an equation, pi r squared, area is pi r squared, to find the theoretical area. And I may be spelling it right, but there's the wrong units there. Did I put the wrong units here too? I did. So area is in centimeters squared. There we go. Beautiful. I'm still going to use these diameters of 1, 2, 3, 4, 5 that I measured before. And the radius you could, again, just like before, you can find the radius with your calculator, which would be pretty pathetic if you needed a calculator to find it in this case, but you can find it with a calculator. You could do it in your head, but let's practice using an equation. I know the radius is half the diameter, so I'm not going to type in 1/2 of 1. I'm going to have it do the same. I'm going to type in an equation or the formula once, and I'm going to have the computer, the program, do it for all the other values. So this is in, the diameter here is in cell A2. I'm not going to click on it. I can type it in. That works too. Divided by 2, because it's half of it, right? So to take half of something, you divide it by 2. I'm going to hit enter. And it gives me that value, and now I'm just going to drag it down. There we go. So those are the radiuses, the radii. The experimental area, I just calculated the area of a square outside the circle and a square inside the circle, and I got 0.75 for the first area, and I got 3, and then I got 6.75 and 12. And finally, I had 18.75. So this is these are the values that I got using that method. I know that there's an equation for area. We said it before, it's pi r squared. And look at that, we already know how to handle pi. So pi, remember, is just pi open and close parentheses, and that's pi. You don't put anything inside the parentheses. Multiplied by the radius squared. Here's the radius. To square something, you're going to put a caret in, that little symbol over the number 6 on your keyboard, to the power of 2, that's saying. So it's saying whatever's in B2, square it. Raise it to the power of 2, multiply it by pi. I'm going to hit enter, and this is what I get. I'm going to drag this down so that it does the same calculation, and look at this. I have all the data here. I'm ready to make a graph. So I'm going to highlight what I want in my graph. I want these 3 things. I want radius on my horizontal axis, and then I want 2 lines, one for experimental area, one for theoretical area. Go into charts, choose scatter. We've done all this before. And I get this. Oops. I get this thing, which is just beautiful. Look at this. And it's clearly not a line. So I'm already thinking when I choose my trend line, this won't be linear. And I don't expect it to, right? Because the area is not proportional to radius. The area is proportional to radius squared. So if I did area versus radius squared, I would get a straight line. But area versus radius, I don't. That's not the relationship between those two values. So let me put a title in quickly. Your title needs to name both variables. So this could be area versus radius. You would write it out if you were handing this in, unless you're very lazy. This would be radius down here, and on the vertical axis we would have area. Now let me add a trend line. I'm going to right click on this point, add a trend line, and then automatically you can see put in a line for me. I know this isn't a line, I know this is a power. If I didn't know it was a power, what I could do is try different things and click around and see, this would work too, and see what fits best. But this is a relationship, it's proportional to the square, right? Area is proportional to the square. When I square something, that's raising it to a power, so it's power. Display the equation, display the r-square value, and this is what we get, and this is not surprising, hopefully. Let me just make this a little bigger for you. This is saying that the y-axis variable, which is area, equals 3.1416, a constant, and that constant's pi. times the x-axis variable squared. This is saying area equals pi r squared. And area equals pi r squared. So this is, again, not so surprising for us. The r squared value is 1. Every single point is on the line. Now let's look at our experimental area. I'm going to right-click, add trend line. This is going to be power 2. Why is it going to be power? Because I know the relationship between area and radius is that area is proportional to the radius squared, which is a power. I also know that because of the math that I did. I was using areas of squares and that's side squared, so I know that that's a power also. I'm going to display the equation. I'm going to display r square, and I get a perfect r square value because I calculated these values by applying the same equation over and over again. I didn't actually measure anything, right? I measured diameter and got 1, 2, 3, 4, 5, and everything else I did with an equation. So we would expect the points to all fit on the line because I kept using the same equation over and over again to get these points. So in this thing, in my data here, the experimental, it says y equals 3x squared. So area equals 3 times radius squared. What's the difference? The difference is that my value of pi, that constant, that proportionality constant between area and radius squared, I got as 3. It's not 3, it's 3.14, and so forth. It's pi. But this is pretty good. This isn't bad. So now I want to put this into Microsoft Word. First, maybe I want to put some grid lines in here. So I'm going to highlight, I'm going to move my data table over first. I'm going to highlight everything and go into format cells. Now there's a lot of things actually you can do. Now that I highlighted this, I can go into table and I can pick one of these table styles and I can make it different colors and things like that. This isn't an art class. You don't have to make it super pretty. You have to make it clear. It needs to communicate information clearly. So don't spend a whole lot of time trying to make it look nice. We want to make it look decent, but we don't have to go crazy. So cells, I want to format the border, and I want lines everywhere. So I put these lines in, and I see that things are still kind of outside the border, but I'm going to see when I put this into Microsoft Word, it's going to sort of sort itself out to a large extent. I right-click, copy. I already have Word open. I paste it in there. It is. Oh, I didn't spell experimental right. Huh. Very close though. So I'm going to highlight these things and make them bold because they're headings. And I also want them centered. So I go into table layout here in Word and I'm going to center them. I also want my numbers centered maybe. So I am going to go over here and center them. So I have my values here. I can make them bigger if I want. I can center the entire chart. I can highlight it and go and center it. I'm going to have to put a caption in here. And we'll go over how to do that, I think, in the next video. So the table's in here. Now I want to get the graph in here. I'm going to click on it. I'm going to hit copy. And I'm just going to paste that right in here too. And I can see when I pasted it that it made it a little smaller. It had to make it smaller to fit it on this page. And so here where I had made my equation and the r square value so big, now they're kind of too big. So from right within Word, I can highlight that and I can make it smaller. I can highlight this, I can make it smaller. And I also noticed now that I'm in here that I didn't put units for my radius and I didn't put units for area, and I know I would lose points for that. So I'm going to put in my units here, and I'm going to put in units here for area, which should be centimeters squared. I put it in the wrong place. Hang on, let me fix that. I put it in the wrong place twice. So you put it in the right place when you do it. I've given up on that. So it's all in here. I can put in the next video, we'll learn how to put in equations and captions. But here it is. I can change the color and I can change it from here. Let's say that I don't want this to be red anymore. I can choose my marker fill and I can make it black if I wanted it to be black. So I can change that color. Oh, I think I only changed the inside. I would have to go back in and change the outside. So you can mess around with this a little bit. I can change the type of line once I'm in here. And you can change it right from Word. So you don't have to go back to your original worksheet to change it, which is very nice if you do it this way. And that is the end of this.